Sampling and noise. Here we have an analog signal to be sampled, but in reality every signal will have noise on top of it. If this is the total variation of the actual signal from the minimum value to the maximum value, the noise might vary by this much. The greater the number of bits for each sample, the closer each sample will match the original signal. But if the resolution is too high, we'll capture all the wiggles produced by the noise as well. The maximum resolution, i.e. picking up the original signal without picking up all of the noise as well, is limited by the ratio of the total variation of the signal to the noise variation. The maximum bits per sample is given by the log to base 2 of the total variation over the noise variation, or B, maximum bits per sample, is equal to log to base 2 of the total voltage over the voltage of the noise. Here the signal and noise are measured in volts, but as the units will cancel, any units can be used. Note both these equations are included on the datasheet. So if a signal varies between -1 and +1 volt, but has a noise variation of plus or minus 10 millivolts, the total variation is 2 volts, and the noise variation 20 times 10 to the minus 3 volts. So the maximum bits per sample is given by log to base 2 of the variation in total voltage over the variation in noise voltage, which in this case is log to base 2 of 2 volts over 20 millivolts, which is the log to base 2 of 100, which is 6.64, meaning the maximum bits per sample is 6. Note that we have to round down here to the largest whole number. If we rounded up to 7 bits, that would be greater than the maximum of 6.64, and so we would capture some of the noise.